Hello, how are you? This is the TermPaper research project presentation for CPSC 5550, which is computer networks slash client server systems. And this is being presented to you by Jeffrey Wade. That's who I am, and I've created this PowerPoint presentation based on this article right here, which is the research article that I have written. It's really a survey, the analysis of performance of the networks, stack architecture, and stack architecture technologies implemented by websites that render, stream, and store multimedia. And that's kind of broad. Websites and applications as well. I guess mobile applications moving to mobile web would also be considered in that realm, because many of those applications, mobile applications, mobile applications do incorporate multimedia into their product somehow. Okay. The outline of this presentation will go basically. I'm going to talk about the purpose of the presentation and the paper itself, the reason why it was written, give a little bit of background information, and then speak about the research that was done and the article, or that should say the paper itself. The purpose, this was obviously written for CPSC 5550, computer network slash client server systems. It's our networking TermPaper project. It was written in LaTeX, or LaTeX documentation language. It is based on a choice of topics that have to be related to networking in some form or fashion. Basically, in brevity, that's the guidelines of the topic choices and the topic chosen. Background information. The topics had to be network related, e.g. Big data, cloud computing, automotive networking, etc. Topics should be chosen from the IEEE website and or the digital library of the ACM, the Association of Computing Machinery, which is, I actually really like the DL.ACM for doing research. Some people prefer IEEE, possibly. Both are very good. You can find quite a few things on both websites. But I had for this particular project, I had more luck with browsing the ACM. Okay. As the name of my research paper might suggest, websites and applications that render multimedia. The analysis of the performance of the networks, stack architecture, and stack architecture technologies implemented by websites that render, stream, and store multimedia. And for me, this is kind of a big. It was a topic that was very broad, had a very large scope. We had to meet a page limit of 7 pages in our paper. I could have easily, I would love to rewrite the paper, or actually just extend the paper, because I had so many ideas flowing, and I actually had to chop off, edit, and remove stuff from many sections and remove other sections as well from the paper. I think it would have been easy for me to go 20 pages, but it's also a survey paper. Okay, with that said, with all the sources that I had, I gathered a lot of knowledge, and I had to do a lot of inspecting. Literally hundreds of pages of research papers were read that related in some form or fashion to the rendering of multimedia. And I don't mean just the rendering on the application layer, so to speak, even though I do. I mean, as well as their network architectures and their stack architectures within the back end system and the back end services of a network of that particular mullet There will be no mullets around here. Okay, you're gonna have to have a better haircut than that. Just playing. All right. Sorry. So continuing on. That's could have been very easily could have gone 20 pages on this, and I would like to extend it. I would love to extend this. I feel like I could actually come up with something to get this published. One of the reasons why, personally, this is interesting to me is that I'm really big into full stack engineering, and from the data side on through, um, you know, the fact everything about the way I compute is kind of like makes kind of it's kind of like just sculpted me for like a full stack engineering sort of, um, in a way. This is the reason why it becomes an interest, and I'm also really interested in big data. I have other interests as well, but so those two, when you talk about those two, cloud computing, big data, and full stack engineering, those three things can go very easily hand in hand when you're when the conversation and topics of networking comes up. Okay, um, so and I'm also really big into multimedia. I really like music, pictures, photos, and films. Okay, that's me. I'm one of those guys. I love listening to music, and I do like to watch films. Okay, so with that said, um, over the past 15 years or so, advancements in technologies, semiconductor technology and hardware technology, as well as cloud computing technologies, have really created a, you know an underlying foundation for massive computing to take place over the web, and there's been just a tremendous amount of sites and applications blowing up. Not as well as not to mention mobile computing, but there's been a tremendous amount of sites that have come up in the past 10 or 15 years, and or apps, and it's caused this helped to yield an explosion of the Internet of Things, of the web. It's really gotten big. The web is 15 years ago. Actually like 20, almost like 17 years ago was the first time I got on the internet, and the internet has changed so much in the last 17 years. That makes me sound really old, but yes, my brother is probably the same way. He was on the internet when he was like 3 or 4. So um, here he is. He's graduating high school, so this year. But he probably feels the same way as he's gotten older. So, but it's caused large volumes of data, big data due to a large number of requests. There's lots of sites out there. There's these sites have got to fulfill their user requests, and do it in a very timely fashion in order to keep their user base happy. Especially with multimedia, the rendering and streaming and possible storage, uploading and downloading of such things, finding the requests and finding whatever they're looking for in order to render, stream, or within the network. Okay. Obviously, the popularity of sites and applications, that there is a correlation for sure, that within the sites that are and the applications that are very popular, e.g., for instance, Snapchat, Instagram, Twitter, YouTube, Kaora, Spotify, Flickr, WhatsApp, Tumblr, Facebook, going on and on. They all have. It seems that all of those sites have got allow users to interact some way or another with multimedia. All right, either the uploading, downloading, storage, streaming, as have mentioned here, they have coordinated the multimedia into their service some way or in some fashion, and that's a big thing. So, how a network, how they are building their networks to achieve and fulfill all these requests for such large amounts of data is of interest to me, and probably to I guess to lots of other people in the world. Anyways, pictures, videos, music, whatnot. So while doing this, I kind of felt like my topic was kind of broad, and I wasn't. I don't know. I couldn't find anything that really related to what I was doing, and so I kind of went with looking for ways to expedite the transaction, the transmission, and the receiving or rendering of multimedia. And I had this ideology when I first started of coming up with the perfect network stack in order to do this. Okay, and I realized how just crazy that is. It really depends on the products and services of the organization themselves. And so then that made me think, well, if I was going to do this, what would I do? Okay, and how would I view going into an application? How would I view building a network? And what key things would I think about as I was doing it? And not one thing in particular, but I wanted to have a set of goals if that's what I was to do. So um, that kind of came across at some point in time as well. So I decided to review and inspect a bunch of articles that related to the following: programming languages, data storage and retrieval technologies, and web technologies, and many organizations too. Facebook. I did look some at Google, but not as much because they do have Google Images, but not as much as I do like the fact that the way Google mines data, and I do like the fact the way they initially, they were kind of a trendsetter early on in the day, back in the 90s, the way they built their Google prototype and the dynamics of the architecture of the engine, and the way they basically laid the foundation of the network they use for the engine. So I did review them as well. Uh, but many organizations, Kaora, um, YouTube, yeah, Amazon was even looked at because they do stream a lot. They do stream a lot of data, a lot of pictures of things that are for sale. eBay was also looked at. Snapchat was looked into. Twitter, WhatsApp, even though that's a blogging kind of a micro, or that more like a messenger app. WhatsApp is an incredible application, and what they've done is very, very unique, and it really is amazing. But with that said, I am continuing. So what about startups or infant websites, applications? What do they do? That's sort of kind of what I was thinking when, after a certain period of time reading so many articles and looking at these sites, I was like, well, what do they do? What would be the approach that they take? Sites and apps that do or will incorporate multimedia into the product, and how will they expand their network with user growth if they become more, if their app and product becomes more popular. And what about expansion of products, the product and services offered? Like what if it's just not one thing, you want to offer something else? How would you go about that? So, and then the dynamics of the stack is in general, the backside of the network stack as opposed to the front end of the architecture. Not to be confused with like front end development and back end development, but that's it. So and then it kind of went to the network, and data storage and server placement. Like what are some key features within the network and data storage, and is this based on like just the amount of nodes, with the filters requests and they're being received, and like load balancing, and how does this affect um, is scalability coming from purely adding nodes? And how does that affect elasticity? That questions upon questions upon questions started arising. So continuing on. So in my paper, I came, I started looking at different, as I said, different organizations, and reading many research articles, and it was like, there's front end of the networks and stack architectures, and there's the back end, and it seemed to be that, there's all kinds of options you can use, like, ASP.NET, and as far as like stack architecture goes, with SQL Server, different things like that, the LAMP, which would be, I'm not biased here, even though that's all I use is Nix systems, but Linux, Apache, MySQL, a base, which is basically like a Nix-based system with a web server, basic structure of a Nix-based system with a web server with some type of RDBMS, and the programming languages for application code. So, and then also programming languages that would be used, like on the back end of the stack architecture. Back end of the stack architectures. Sorry. So all those things were taken into began having thoughts about that as well. So with that said, I kind of devised, started thinking about and outlining all this stuff and documenting all this stuff that I was coming across, and noticing common trends and different things like that. So on the back end of the stacks, there can be different strategies and implementations used, many different technologies, in programming languages as far as load balancing, data storage, caching, expediting processes, just trying to optimize on in many different aspects and many different levels of the stack in general. And there was I spoke of languages and frameworks, APIs, both client side, server side, and networking. All of those are going to be done with some type of programming language and an API, and then for middleware and data integration and content management. As an organization or a startup or an infant app would build their platform and build their product and their site, all the different stuff that the programming languages used, and it was noticed that many of the current organizations are using more than one language. Okay, besides just like on the back side of the stack, or more server side, more towards the server side of the stack, I should say. So like client side would be like would be the front end, would be what's ran on a client's machine through the browser. You would have like JavaScript, HTML, CSS, maybe some type of JavaScript framework variant of some sort, and then for server-side networking, there was a common trend of there was all kinds of different languages used. Didn't seem like there was like us versus them as far as like what programming language we use. It seems like the many organizations were using the certain programming languages they use to get the job done, whatever seemed to fit was best for the task, I should say. Lots of C, lots of C++, PHP, Erlang seems to be very popular with the messaging applications, Java, Ruby, Go, Python, Clojure, So all of those, etc. Perl, server-side Swift, or Swift. I guess Objective C would also fall into that category. And then for Windows-based sites, there are some of those out there. You'd have, I guess, ASP.NET and possibly F and C Sharp. And so, continuing on. So then, went to like web technologies. Of course, that would have to be brought into the discussion, like web server softwares and things like that. Delegating requests from the front end of the stack, handling it back to the back end of the stack. What would be the approach on that? As time, going through time as time evolved, and the popularity of a particular app. Could they be handled with scalability and elasticity? How would that go about happening? Like load balancing using a reverse proxy server, and all the different server types of, well, not all, but there was many server types mentioned, or I should say server distributions mentioned. Tornado actually was mentioned. SQL server was mentioned from Windows, or Windows Server 2012 was mentioned. Tomcat was mentioned. Nginx was mentioned, and Apache. But it seems like out of the current organizations they're in existence, Apache and Nginx are at they seem to be at the fore favorite currently. With all their technologies and with their capabilities. And Apache and Nginx they're actually quite different. They're quite different species. I wouldn't say species, but they are different. Okay. Yes, they are both HTTP servers, but what they can do and how they do things is much different. The way their individual architectures and the way they handle things is much different, as far as like processes, implementing modules, load, and things like that. Nginx can actually be used as a reverse proxy server at the front end of a stack architecture, and route and handle URL requests to more to the back end towards Apache, or to another line of servers behind the reverse Nginx. And what application code, or I should say what programming languages can be used on the two servers, also varies. Apache seems to be more open as far as what programming languages can be used, whereas in Nginx there was certain issues with what languages can be used, and there had to be configurations and things done to allow like PHP to run on Nginx and other languages. Data storage and retrieval. Okay, so there was common trends between the website's reviews and the while researching, and the articles used. Of course, this is a huge topic to me. I do have a little bit of skills as a database admin. I do like administering databases and getting it set up, so to speak, as far as on the data end and the data warehousing end. So data storage and retrieval is important, and it should be important when you're talking about fulfilling requests on for numerous users, potentially numerous users at once, coming from different clients' computers all over the world, or different clients' computing systems, which tablet, i.e. smartphone. So we're fulfilling those requests and getting accessing data, finding the data wherever it's stored at, and then performing what was asked to do by the user on the user's request, through the user's request, is important. So on the RDMS side, there's many choices that you can choose from. There's many choices you can choose from when choosing an RDBS database, MySQL, Oracle, MariaDB, which is like sort of, I wouldn't say spin-off, but it's sort of like a spin-off of MySQL. The same people who founded and developed the MySQL, or one of the heads of the one of the founders of the MySQL project is actually very is one of the people backing and pushing for the MariaDB project to go, and MariaDB is completely open source. There's a lot of politics involved, or business and other stuff that's going on. Oracle has bought some microsystems bought MySQL. So, of course, now Oracle, who's like the king of databases, as we all know, and distributes just about every database known to man, is distributing MySQL. That was very facetious, but they do distribute quite a few different database distributions of different database types. Okay, and so then also NoSQL was touched on as far as NoSQL databases, the hypertable, HBase, which are both wide column or family column value or column family stores, and then Cassandra and other. This really should have an etc. in there. Many types of NoSQL databases were covered. Key value stores or whatever, and in-memory key value stores. Research into specifically in-memory key value stores, as in, i.e., Mica and Memcache, were both reviewed as pretty heavily as well, because, of course, requests that are frequently used, you would want access to those, or wherever that data lies, to speed up as a caching of sorts, to speed up request fulfillment. And other topics that were looked into within the course of the research done. Excuse me, hybrid network infrastructures, meaning a combination of using cloud computing concepts and technologies, strategies, implementations, or whatnot, with like Hadoop, HDFS, and then like clustering Memcache, and getting it all kind of jointed together to where it's just meshly, it's just very smoothly flowing. That's all of that has got to take place in order for an operation to run smooth, and for true optimization, in a sense. Well, not necessarily. Cloud computing within a network infrastructure is important because it maximizes resources, of a sense, and also allows, I would think, developers and users to, or I should say, developers and engineers to better develop the future products, or maintain current products and services. And Hadoop seems to be a pretty useful memory and backup for a lot of these websites. I've actually installed Hadoop, a Hadoop cluster, a few different times through both Google and Amazon Oz, using some cloud, doing some cloud administration, and it's definitely effective. That is for sure. Okay. And Hadoop Hadoop in itself should be clustered in order to optimize its capabilities. Right. And so after doing all that, and explaining my thoughts, I came up with what we thought would be the advice to startups and infant website applications. And And that would be always think about the future, whether it's scalability, growth, implementation of services offered, limitations of current technologies, uh, what or whatever. Keep in mind that at some point, the elasticity of this as we expand. What if we offer this into the product that we currently have? All those kind of play a role into how you want to approach things as far as starting out, and potentially even after post starting out after, towards the going towards expansion. That could be like 2, 3, 4 years later, even for some of these sites. Okay, so avoiding paying licensing agreements for technology, that's more of a business thing, but there did seem to be a common trend between the organizations of the 15 or 20 organizations that were looked at. Most of them avoided paying license agreements for technology. They came up with ways to they either created their own or used something open source, some type of Linux backbone, with, as it was previously described. Set goals for developing replacement technologies if indeed you feel that there is going to be licensing agreements, or you feel like, or if the site and the organization feels that they are encroaching on potential limitations of the technology. Okay. Create services to optimize scalability, provisioning of elasticity, analytics, task management tools, etc. As opposed to paying license agreements, that's probably a better way to approach things like that. Putting in more code, adding in more intellectual property to the and more engineering to the organization. Use the programming language that is best suited for the task at hand. That seemed to be something that was kind of, wouldn't really stick out at first, but once reviewed, talking about hip hop, the fast iterations of PHP that Facebook uses, Erlang being used by WhatsApp, and I think Instant Messenger as well. Different things like that. It might not necessarily be I guess when creating a service, or coming up with a way to complete the task at hand. There might be a smarter solution as far as programming languages go, and it never hurts to think about that. Okay. One suggestion might be, as reviewing some literature, would be look into possible energy efficient GPU options for key value store caches. Those things are very, very fast. They can handle more workload. So, of course, in key value store caches, there's going to be a lot more requests within the key value store cluster, and possibly using GPUs would optimize the speed of the return of those, or the fulfillment of those requests. Okay. Look to optimize the stack architecture with a holistic approach. Kind of, if instead of just concentrating on one part or one service, how would that affect other services within our stack architecture, in the network? Try to come up with a more well-rounded, if that is the case, try to come up with a more well-rounded approach. Realize that it is okay to draw inspiration for ideas from other organizations' implementations. As far as on the back end, if you could, it doesn't seem like it would be anything wrong with inspecting some other organization's stack, and understanding what's going on in the different stages of their network stack architecture, and and drawing, maybe possibly drawing ideas from there whenever there might be some confusion about something. Okay. Number 9, do not be afraid to discontinue a technology or component of the stack architecture in favor of another one. If you need to do that, I would think that that should be okay. It's what we kind of came across, and began thinking, because it's sort of like uh, we need to find another solution, because this is no longer accommodating um, our expectations. When we no longer have the same working model as we once did, now that either users have gone up or we've integrated services together. Okay. Number 10, do not use the same technologies to deploy all services throughout the network stack. Mix it up a little bit, create data, and perform analytics. And by that, I'm saying specifically, just because you're using, because using something like Redis or something as a NoSQL server, or NoSQL data store, there could be another option for using for something else if it plans on doing something else. If you're offering multi services within your product model. Okay, if your product model has expanded. That seemed to be something else that was taken and seen at various stages in various other people's or other organizations' work, and in the research articles that were covered. Okay, when radical changes are made, do it in phases through the network architecture. As far as like implementations go, if all of your server-side stuff is written in one language, for instance, but there's wanting to do in, say, a test trial of one framework, you found that this framework to be, from performing the analytics of one framework that you've integrated, you found this framework to be have greater scalability of some sort. Do that, phase that new framework in, increase over time the amount of nodes that are going to use this framework. Okay, that's sort of the advice that's meant to be taken there. Okay, and with that said, in conclusion, building a network stack to incorporate multimedia can be a different and difficult task. It can be very difficult. That's the reason why engineers do what they do. That's the reason why they're so good, and we have the apps that we have. Okay, worrying about the stack at hand. Use the tools that are best for the job. That's kind of what the job, meaning that the job that is going on within the organization. Okay, based on whatever else is integrated. At some point in time, you're going to have all this stuff that's integrating and finding ways to integrate it all together. It's going to expand. It's going to expand. So it's at some point in time, you're just going to be like, we gotta start thinking about all this stuff together. And not just thinking about it from the standpoint of one division or one service. Okay, try to keep an idea of expansion in mind, because that's ideally what you want to do. Maybe not in products and services offered, but in user growth. So you got to think about scalability and elasticity as well. And with that said, of the network itself, my acknowledgments. We'll go to CPSC5550, Computer Networks and Client Server Systems. The instructor of the course is Dr. Farah Kanda. He is a great professor. Guy's a super Java programmer, hacker. I think he got his He's really good. He's a very, very knowledgeable as far as in networking protocols and in network applications, Wi-Fi, the Wi-Fi encryption, things like that. I think he got his PhD in something related to Wi-Fi uh, cryptography or Wi-Fi encryption, programming Wi-Fi encryption. I think from the University of Nebraska, and of course the University of Tennessee at Chattanooga, which is where I am. Um, a graduate student, and I am a master. I am a candidate for a Master's of Science in Computer Science with the MSCS program here. Okay. Um, and I have a tremendous amount of references. I am not about to go through all of those, but as you can tell, there was a lot of work covered. Not to mention a lot of websites looked at. So I am calling it quits, and for the viewers of this, I will eventually integrate this into my my video share. But for now, I hope there is only going to be my professor who sees this. So with that said, I hope you enjoy it, and goodbye.